Halo pemirsa yang nonton stream kita, mungkin yang tertarik dengan programming di bahasa Golang. Welcome everybody, because I'm going to speak in English most of the time. Jadi hopefully everybody in the world can learn together and give me correction if I make mistakes about programming in Golang. Maybe they have a better approach to achieve some logic and give me advices. Let's learn together. So we going to continue from our last stream. So basically the idea is I want to create an application that do server uptime checking, pretty much like uptime robot. So the application will call a server using a URL and then do a HTTP request. Could be on get method, put method, post methods, whatever method they might be, and then get the response and then make a validation whether a request is successful or not. Because when you have a checking task, you should be able to identify whether a request or checking is successful or not. Even though a request is successful, doesn't mean that the monitoring is successful. For example, if the monitor say that you should call www.xyz.com and then the result is 200, but it takes 10 seconds to do the request, while the requirement is it should be done within 5 seconds, then the monitor is considered to be failed. So we can say that your performance is been dropping while the latency is more than 10 seconds. So there is something wrong with your server. So that kind of request we going to do. So this program that I'm creating is actually a very simple application or logic that will call the server or a HTTP server and then get request. And then let's see whether the request, the monitoring task is actually successful or not. So the monitoring task will have requirement, then this program will do the job, and then from the specification also we can see that whether the monitoring or the call is successful or not. So let's continue. Okay, we picked up from our last program. Last time we have a job, monitoring job, and then a job should have an execute command, and there is a context that a job should work on. So the context is actually the definition of what is the monitoring parameters, configuration, what should be done by the monitor, by this application, by this logic. It contains what URL to invoke, method to invoke, and also this context also will store the execution results, the HTTP call results. So the job context, this is where we could store all information regarding the request and also regarding the response. So the default context is implementation of job context. So we have all the methods implemented, and the job, we create an HTTP check job. HTTP check job is implementation of the job of a job. So we have a function that implement the interface. Okay, let's continue on. So last time we do a test. This test, we prepare a context that the request URL is very easy to actually read the context. The context said that the context is very much like a map. It's actually a map backed by a map of a string to a string. So the string, the key will be http.request.url. It specifies the request URL to be called by the HTTP client, and then this URL will be called using a method. We put a key http request.method to specify the method, and then we create a new job, and then this is a HTTP check job, and then we simply execute it. So let's try this once more. Let's run it. So it's written 200, because we can easily say that we just logged out the code. It will be inside the context http response.code, because that's the logic. So last time we get the URL to invoke from the context, and then get the method from the context. We make sure that the URL is there and also the method is there, and then we make a new request using the method and the URL to invoke, and then we create a new HTTP client and we invoke the client. Very, very simple. So what we're going to do next? Okay, maybe we can put more information inside the response. We already have response code. Maybe we want to put headers inside the response, inside the context. So we can put something like job context.set. Maybe we iterate through the response header, and then we put all the header inside the context. Good idea. So let's do that. We could iterate through the response dot header dot how can we iterate through headers? Headers is actually a map. So let's do like this. For header key, header value, is a range of response dot header, and then, well, what do you know? HTTP. Is there any constant to use to access some kind of headers, like content type? No. Or we could iterate through the header based on the specified standard header. If it is not a standard header, then we have to do something about it. So let's open a standard header specification. So let's go to HTTP header. Okay, HTTP response headers from Mozilla. List of all HTTP headers. Whoa, there's a lot. Oh. There's a lot of header that we can process. So we have to do this. How can we approach this? It should be coming from the context, isn't it? It should coming from the context. So wow, gosh. So let's create another file. So Golang file, so we can focus on this. We call it header, HTTP header. So what we're going to do is function extract header. Extract header from an HTTP response. Okay, let's see. HTTP response is actually in what? It's a pointer to response. So the pointer to response and context to extract. So we're going to need context, job context. Okay. Extract response header. So what we're going to do, we're going to look for all of these headers. This is the standard headers that we have. We're going to look into all of them, and then what we're going to do, we're going to inspect all of them one by one. Yeah, that's what we're going to do. Let's do this for the most basic headers, starting from there, because if I'm going to do this for every one of them, I'm just wasting your time. So I will do this off stream for all of them, but for the sake of demonstration, let's do this. So for some of them, not all of them. So one is one of the most common header is content type. So we just look for content type like that and put the content type into our context. So let's do that. For key value is on the range of response dot header switch strings dot toOpper of the key. So case we get content type. If we get a content type, we put into the context set we could redo this function to be more efficient, but we make it work first. Okay, so if we get content typed, it should be in uppercase, because we make it toOpper, so it's going to be content type, something like that. If it's going to be content type, because we don't know implementation of HTTP server, it could be content type in lowercase, content type for hypercase, or in uppercase, or it will be in the snake case, so, or a camel case, like that one. So we just do that. So the key will be response. Response. Is that how we do it? Yeah, HTTP response. So going to be HTTP dot response dot header dot content type, and then we put the value. So what is actually the value? Value is, I think it's a array of string. Yeah, bug. So we can separate them by way with something. So strings joins value with a comma. There you go. So each of the content type, if there is multiple content type inside the header, because header specification, one header key could have multiple values. So we imitate that capability so we don't miss a header. So this header, content type header, will have comma if it's multiple header values. So we put it like that. Later on, we can separate them using a split. Easy, right? So that is if we have content type. Let's put on a couple more. Okay, let's put on a couple more. Or we could do it differently. We don't need switch. We just put like that, where you will get the idea. We put HTTP dot response dot header dot whatever the header with the lowercase of the key, strings dot lower to lower key, and then we put the value. Wow. Okay. Okay. Oh, missed the comma there. Wow. It is actually very simple. I just think that we don't need to create this file after all. The HTTP header, it will be useless. We just do this. Well, what do you know? Let's put the context there. Yep. Yep. That's how we're going to capture all the headers from the response. Next, we must ensure the response body should be closed. This is something that I learned, that if there is no error when you call a client, HTTP client, and then you obtain a response, then the response body should be closed immediately as soon as possible when you have a chance. So we're going to use defer response dot body dot close. So whenever we exit this function, the body will be closed. All right. So, and then let's extract the body if it's contain a body. So what we're going to do, we extract it. So how to do it? IO util read all. I think from there, what we're going to read, response dot body. What we get from reading all response body, a byte and error. So body byte and an error. So if we get an error, if error is not nil, what we're going to do, we're going to do nothing. Simple, right? We do nothing. So only if there is no error and the body is really containing some data, body byte is not nil, and body byte length, the length of body byte, yeah, length of body byte is more than 0, so it contains about body bytes. What we're going to do, we're going to put the body into the context, but because the context is only can contain string, we could easily convert the bytes into string, or we could put a base 64 string representation of the body into the context. So we're doing something like base 64 dot encode how actually we're going to use base 64 encoding. So GOLANG base 64, go by example. That's good. So what we're going to do here, okay, standard encoding according to string, we put byte Okay, we already have byte, so we get like that. Very simple. So what we're going to do, base 64, something like this. So we don't put byte because we already have byte, so we simply put body byte there. And then we have a body, we have a base 64 body. Right, it returns a string. So then we put very much like that, and then we put header, body, shoot, sorry, I'm very sorry. We just make things so complicated. Simply like that, and then we put the 64 body. There you go. Let's try this, shall we? Where is our test? Okay, job test. So after we get a response, let's show the body if it has a body. So if context dot if ctx dot contains HTTP response body, we just log it out. T.log context dot get okay, and yeah, just like that. So let's see what we get, what we have. Ooh, that's one long big response. We could think of other approach. We should, in fact, think about how to do this better, because obviously if we get a context which is too big, then the communication between the agent and the coordinator will be too heavy. But at least we get what we want. Let's decode it. We want to see in the decoded form. Yeah, very easy. Copy and paste. It always works. Base 64. Standard encoding. Decode the base 64, and then we just lock it out to see the actual content. Run it. Oh, it's a byte. Oh my, yeah. Let's cast it into string. String. I'm sorry guys. That's how you typecast, right? Oh, this is embarrassing. I don't know how to typecast to string. So, cannot convert expression from byte. Error. Oh, yeah. Oh, yeah. I'm very sorry. we have an error. So this is the string body and an error. So t.error. So we just show the error if there is an error, and then we just popped the body in the test log. So let's try this once more. Woo! Oh my god. We have to typecast here, of course. It's my mistake. This is not string body, this is a byte body. Well, silly me. Oh! There you go. We get the body HTML. Yeah. If error is not nil. Else. There you go, that's proper. Look at that. This is the response code from there. Right? No? Yeah, this is the response code, this line, and then this is the response body in base64, and this is the actual body. Then we want to see the headers. So how we can get the headers? We just iterate through the context response header. So let's iterate. Hold on, I'm thinking, because I want to iterate through the internal data of the default context, the data. Well, we don't have default context. We only get the job context, right? Because here you can see new default context is actually returning a job context, so we cannot access the internal part of the context. So we must have an accessor to the data, to the data. Yeah, to the data. How are we going to do that? Well, for now, let's simply get it. So get map. We're going to return a map of string to string. So let's implement this in our new context. Let's do that. It's easy and fast, right? And simply return the context data. Why we make it like this? Instead, it just make this data to be public. No, because we want to have an accessor to the data. People should not get direct access to the data. Because later on, when we need to control the map, maybe we should return an unmodifiable map or any kind of implementation, any other implementation, then we control from this get map. Right now, we just simply return the data. Okay. Okay. Now what we're going to do, get the map in our test, and we pop out all the headers. So for context, the key and the value inside of context ctx dot get map. So we get the map. We just show everything for now because we just want to look at it. So we just logged out something like print out header of key is a string with a value. The first is the key. Second is the value. Right, so let's see. Whoa, we get all of those headers. Header, response header, yeah. We only interested for those which have this prefix, the HTTP response header, and then whatever the suffix is. So we put a very simple if the key strings has prefix, the key has prefix of that, we pop out the header. Look at that. So from the response, we see that the response have a code 200. It contains a body. This is the base 64 representation of the body. This is the actual body. We can have all the header: date, p3p, xframe option, server expire, x, okay, cross protection, set cookie, alt svc, cache control, and content type. Great. Next, we're going to put in the time taken to execute this HTTP call. So this call, we need to capture the latency, the response time. Sorry, not latency, response time. So what we're going to do, before we invoke, we start a timer, right? We record the time. Where is the call? Where is the call? This one is the call, client 2. So let's capture the time. Start is time.now. And then duration is time since, we get duration, time since start, we get the durations. And then we put the millisecond in value in the response. So what we're going to do, like that, set response duration with something. Let's put like that. We put a value like that. What we're going to put is the duration in milliseconds. So what we're going to do, we're going to divide the duration with millisecond, time dot millisecond. Let's try it out. The durations, this is the duration, so we're going to pop it in our test. T.log I like this as printf because I can format any information into a string and then put it inside the log. I do this quite a lot. So we're going to put duration is a d millisecond. What we're going to put is the duration is in string, isn't it? Context get not get duration. Let's see, run. The duration is below 179 millisecond. You can see that. Good. We've done that. What we're going to do next? So let us evaluate what we already done. So we have an execute for our HTTP check job. So any job which is of type HTTP check job, we can execute those jobs, and it will take the URL and method, simply those two informations, to create a request. And then from this request, we're going to have a client that's going to invoke it. So we have this client with time, the invocation, and then the client call. And then what's next is after we call, we check for error, and then we extract the body, we extract the headers, and put all of them into our context with their own respective key. For header, they have a key HTTP response header dot whatever the header it is under lowercase, and we have error, or yeah, if it's contain error, and also the error reason, the text coming from the error, and then the body. The body will be inside the context. The body will be in base 64 because the body could be in binary form, so we need to convert it into base 64. Later, maybe this application should be even more smarter by inspecting the content type of the response. If the content type of the response is a text, then we don't need base 64 encoding. If it's going to be other than text, then we need to do a base 64 encoding, and then it should be smart enough to know whether the content type, the body actually should be inferred from the content type, right? Otherwise, our client is not that smart. So what we're going to do, before I forgot it, let's put a to-do. It's always a good idea to put some note into your code that something that need to be fixed, something need to be refined. make this smarter. When content type is a type of text, we do not need to convert into base 64. Yeah. Otherwise, base 64 is going to take up space, because when you convert a byte array into a base 64, the actual number of bytes is inflated. Yeah. Okay then. What next? Oh yeah. Requests have headers as well. So what are we going to do with this? Let's make this simple. First, I don't know whether this is a good idea to lower the key of the response header when we put into our context, or just reserve it as it is, because we can put the same pattern where HTTP request.header is whatever the header, we just take it as it is and we don't do translation into a proper header casing. So just put key like that. So we have all the header in there, in their form, in their original form. And then we could do the same for all of the requests. So what we're going to do when we create a request, before we invoke it or to the client, we put the header first. We put the header first. Yeah. So let's copy, because we have done this. We just duplicate. We just redo this. Copy like that from our context, the map, and changes to request. So all http.request.header, we're going to take the header key. It's very simple. It's a key starting from, it's very easy, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So starting from index 20 forward, we have our header key. And then header values is a split the value with comma, because we expect the same when they create a header for the request, that all request header that have multiple values, it should be separated with comma. So we do it like this. So we get header values. Right, the string is just written on an array of string, and then we can put into the request header. Request.header put header key with header values. That's it. So we can do any header. We support any header. in our request. So just put some HTTP request header, something like this, and then whatever followed with the suffix is the actual header that we want to put, and then a value. The value is actually the header content. It will be added into the request. Later the request will be called. Very good. We done this. We can do header. For example, let's create something like this. Context set http.request.header. We couldn't put any header inside. Maybe something like agent, user agent. Can we put agent? User agent. Yeah, user agent. Something like that. With a value of Simon agent. Like that. So our request will be containing the header user agent. And the user agent will be Simon agent. Version 0.01. We should load this from some configurations. Okay. Let's call. There you go. Sadly, we cannot debug HTTP client of what is actually being sent. We can put a sniffer in our call, so our sniffing application could see whether how is actually the HTTP request is being made. So we will know that the header is actually there. But we can debug to see what is the header is actually put. Yeah. I'm worried about whether we actually do a proper split, or whether this 20 is actually correct. So let's pop it out. Yeah, old school debugging. See, user agent. Why we get the user agent? Oh yeah, because this is the key. Yeah, right. Yeah, all right. Yeah. Because HTTP request header dot user agent. That is the thing that we put there. So it is correct. Yeah, can remove that. So we are doing this nicely. Our execute function can create a HTTP call using a URL. We specify the method. We specify the URL. Yeah, URL, the method, the header for request, body, request body. How can I miss that? So yeah, let's do it the same, just like what we did with the response body. So we expect that the request body, we expect the request body to be in base 64 as for now, because like I said before, we should be smart when reading the response body. response body should be in text if the content type is a text. So the same way as the request. If the request content type is a text, then we should not do base64 any kind of decoding when we put the byte into the body, the request body. Yeah. Then we check first if there is a body inside the request. So how are we going to do this? If the context, job context, contains a key which is http.request.body, then we're going to get the base 64 request body. We get it from the job context dot get just like that, and then then we decode it. Again, I have a very short memory. How are we going to do this? We do the decoding, yeah, like this. Decode string. Sorry. And we have a byte body. If error is nil, there is no error, because if there is an error when we try to retrieve the body, what do you think? We put an error, I suppose. Yeah, and then just return. We put like that. If there is an error, we have an error. The error is that, and then return. If there is no error, we'll make sure that the body have content. So if the byte body, sorry, the length of the byte body is bigger than 0, then we put the body into the request. After this, we need to cast it into string. Like, oh no, it's a byte body. We just put it straight away into the request. Request sort dot body dot how we can write this? IO util write file. I don't want to write to file. How we can do this? Not like that, I suppose. Body is a read closer. How to write a binary? How GOLANG write request body. There you go. Stack Overflow save the day. There you go. Yeah. Request. Equals to not closer like that. Byte body. There you go. So we put the body like that. So we can send request body. Yep. The challenge is that if we do it like this, we need to specify the content length. Like that. Yeah, correct. Ouch. Let's copy that. Okay, length of the new body, the byte body. Perfect. Now let's see this again. Our job execute function can take HTTP request URL for the URL to call, HTTP request method for the method to use, and then it can take HTTP request body to put in the request body when needed, and it can use HTTP request header blah 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 to use the header. And I don't know, because here we put request content length like this, but if we have a request header content length here inside the header, will it override the actual content length that we already put here? But let's not worry this now. Because obviously when we put body, the content length should be equals to the body length. Right, it's logical. Maybe we can put this after. We can put this after the processing of headers. There you go. Yep. What next? Let's make it simple. Yeah, this is a to-do for the request. And this is for the response. See, our context is backed by a map. We call it data. So obviously, this context could should be able to store any kind of data type, but in form of a string. So when we put information, maybe in a number or an integer, or extract it as an integer, it must go using the underlying data type, which is string. So the get will be defaulted to string. So when we get a key, it will return the string, because this is a map value is actually a string. But let's make our life easier, where we can do something like this. Get int, get boolean, get float, something like that. This is only a helper function, so to make us easier to extract, it will return an integer, boolean, and a float. The same way with set. You get the idea? Yeah. Ouch. So integer, get integer means that we need to extract the get, but as an integer. So context, get key. Yeah, it obviously need keys, guys. Obviously need key. The value here, yeah, integer 64, boolean, and a float. So yeah, get integer means to get the key, and then we just immediately parse this string into an integer. So what is the integer? E to a integer 2, no, alphabet to integer. It returns an integer. So we get the key. And then this will return an error, the value, int value, and error, something like that. So if there is an error, we return 0. Else, we return the int value. The int value is integer, so let's use integer. Integer is always treated as the platform that is running. So if you're running on our operating system, 64 operating system, then the integer is equivalent to the integer 64-bit. So if you're running an operating system which is 32 bits, then the integer will be equivalent to the integer 32. So I assume today's server is always 64 bits, so we shouldn't care less about that most of the time, almost. What infrastructure as a service right now that is still running 32-bit? So yeah, that's how we're going to do it. Integer and float. Obviously float, we need to specify the actual float, bit, because there is no just float. Float is always 32 or 64. It's either you only have two choices. Okay, a boolean. So we can just simply switch. Let's put the uppercase of to upper of context get key. Case true, return true. Case false, return false. Default, return false. I know, we can do that. Okay. Or true, yes. What is the other representation of Boolean, which is true and false? True and false, yes and no. I think that is all. Okay, yeah. You can use true or yes. Other form will be considered as false. Okay. And float. How we can parse float? Parse float. Yeah. We convert from that with 64-bit. It will return a float value and an error. If there is an error, there is no nil, we simply return float. We simply return 0. Else we return float value. There you go. Like that. So this relies on the platform to know exactly when you put information into the context, you should know beforehand the context value format because it doesn't make sense for the system developer to put value into the context without knowing what is actually the value, what is the format, the data type. So when you put something as a boolean, then you should retrieve it as a boolean. It doesn't make sense if you put something in boolean and then try to retrieve it in integer. So you're going to rely on the brain of the developer. Now, moving to the set. Let's set some integer. So what we're going to do, we're going to set context ctx put set key with a value. How are we going to get the value? Simple. String. No. It's printf. You put it as a float. A float like that with a value. Oh, it's an integer. Yeah. The key is a string. Come on. How stupid. We don't need to put it there because doesn't matter. For clarity reason, we put the string here. Please bear with me. So yeah, put like that, and like that. This time the boolean will be v. This one will be f. There you go. Oh. Maybe we should separate between job and context. Let's put a context. Go file, call it context, and move all context related structure into the new files. Okay. So we have a much readable. Where is our context? No, there you go. Context, we talk about context. Job, we talk about job. Right, so yeah. There we have. Oh yeah, like I told you, we need to do some validations. So how are we going to approach this? Because the context should specify how to make a request and also be able to store all the response informations, and also should be able to specify how to validate the response. Okay, let's do validation. Okay, let's have this separated. Validate using a context. So there you go. To validate, let's make a very simple. Validation. First, if there is a context key called, let's do it, and then you just see what I mean. Okay, let's validate for response code. If HTTP validation we are validating our response, so it's much better if you can do it like this. Response validation code put like that. Then we should check for a response code. If job context contains response code, else let's put job context dot set. Oh yeah. HTTP response valid is false. Reason: missing response code in context. Like that. Right. If there is a response code, we just simply compare between the two, right? Return, sorry. Valid equals to job context dot get valid. Yeah. Valid is equals to the response validation code is equals to we simply compare between the two. Yeah. This response code is 200, then it should be 200. This response code should be 300, and it will be 300. So we just compare between the two. If not valid, we simply put not valid, and then we put unexpected response code. Invalid response code. I think yeah, Other than that, if there is no validation response code, we can accept anything. So we just put context valid to be true. Yeah, we put it using set false as a string. We could use set boolean, but unfortunately job context is not a default context. It's a context defined by the interface. So the interface only have set, so set boolean, set integer, and set float is not exist. So we cannot call them like that. Otherwise we'd have to specify all of those setter and getter in the interface. Okay. What else? Let's try. Job test. How to specify? Yep. Okay. Let's put that into the context. Let's copy this. Specify this. We expect this to be 1, 2, 3. And then let's make sure, let's test if the response is it should be not valid, right? So if context get, we need to call validation. Dang it. Job validate context. What to test? Response valid. Then it should be fail, right? Yeah. Test it out. Yeah. So this should be false. Hold on. What is the logic? We expected the return to be 1, 2, 3, but the code is 200. So valid should be false. What? Hold on. Okay, it should be true. So if the response code equals to the code, means this is valid. my god. My head. So what is actually should be there? So if the code, the response code equals to the validation code, means it is valid. So if it's valid, it's going to here. If it's not valid, it will return false. Yeah, oh my god. So if it's true, then we have problem. Yeah, it should be true. It should be true. What is happening to me? We expect the validation code to be 123, but the response is 200. So if we specify the validation code, it returns true. If we don't specify the validation code, if we specify the validation code, it will check to the response code. If the response code is not there, then it is not valid. If the response code is there, we check whether the response code equals to the validation code. If it is validation code, not equals, let's make it like this. It's not equals, then it is not valid. Yeah. So response valid is actually true. It fails. What the heck is happening? Okay, let's debug this. Expect actual so we expect it to be this, but the actual is this. So it never get in. It always get out. Wow. It always falls. Because it doesn't contain response code. Let's look it out. it's true. Let's lock it some more. What we are looking into, that one and that one. They are different. You can see they are different, but they say that the response is valid. Something is wrong. Oh God. Where is I look at this. We have a, oh, haha, my mistake. Let's see. So actually, it is actually getting to this. Silly. Old school debugging. I know it's going to be not valid and then valid, something like that. But at least I need to see whether the not valid is actually coming out. Old school debugging. I like old school debugging. It's easy. So what we have here. So it is not valid. It goes in here. Oh my God, it's always set it into true, isn't it? I'm a donkey. I'm a donkey. I am a donkey. What we are aiming here, if it is valid, it should not be valid. Yeah. Dang. Yeah. There you go. We have it. We nail it. I'm just tired, maybe. Yeah. Just tired, maybe. There you go. Yeah, we next time we're going to add more validation. Yeah. Right now we are validating for response code. Later on we can validate for duration. We can validate for header existence. Right now we put HTTP response validation code means that we can only validate for one code. If we put like the example, if we put 1, 2, 3, then the response code should be 1, 2, 3. But how if we want to validate for multiple response codes? It will be valid if it returns 200 or a range of number between 200 and 300. It can be 200, 201, 202. All of these response codes will be valid. If it's other than 200, then it's going to be invalid. If it's it will be valid if the response code to be 200 and 202 only. 201 will be invalid. Those kind of things. So this validation of code should be it could be a value, or it could be an expression to validate the value. Yeah, this is the beauty of our validation mechanisms. So the user can validate their response from their server with very dynamic expression. Isn't it good? Yeah, expression is good. Yeah, but that will be the subject of our, that will be the next discussion on how to do validations. And of course, another come into my mind that our validation should be able to be done in a chain. For example, we want to make sure that a login or a dashboard to be working. A dashboard should be working when we call our HTTP server. We expect a dashboard. It should be working. But in order to get this dashboard, we need to log in first. So we have to make the first call, which is the login, and then we have some validation or some session or whatever, and then we do some of this response from the first request to be used in the request on the second request. The response, for example, session could be token. It will be utilized in the header of the second. So we must be able to embed those parameters into the second request. So the response from the first to be used in the second. Yeah. Again, this will be our next task. Okay. I think that's it for now. We're going to continue this again next time. Thank you all for you who follow or watch this video till the last. Means that you're really interested on how to code Golang with me. I know some of this may be boring, but this is what programmers do. Do boring stuff, develop something, create magic. Thank you guys, thank you all. See you again